with my final Kaggle capstone project. My name of the project is Invoice Processor. So, processing involves manually is a slow and risky bottleneck. In finance teams, it often leads to accounting mismatches, fraud exposure, compliance issues, and handling of a sensitive data like a credit card numbers and IDs. Today, I am excited to present Invoice Processor, an intelligent, secure agent system designed to automate invoice validation while keeping humans in control when risk exists. What it is? Invoice Processor is an AI agent system built using the Google Agent Developer Kit ADK for the agents for business track. It acts as a structured multi-agent financial auditor that extracts invoice data, verifies it against purchase orders, detects security threats, escalates decisions to humans only when necessary. This mirrors how a real enterprise finance system operate. So coming to the design principles, so there are three design principles I have used here. So the core design principles of the system are first one is an automation. So for automation, I have used a multi-agent collaboration as I show you here. Multi-agent collaboration. Next one is an security. So for security purpose, I have kept an a secure checkpoint. Next one comes the intelligence. So for intelligent purpose, I have just integrated the MCP integration. Instead of hard coding, I have just integrated the MCP here. So all working together to reduce manual effort while maintaining trust and compliance. So why did I choose AI agents? This problem cannot be solved reliably with the single LLM prompt. Invoice processing involves multiple independent responsibilities like security filtering, data extraction, policy verification, human approval for financial risk. That's why this project uses a multi-agent architecture where each agent has a single well-defined role. This makes the system safer, auditable, and production ready. Next, I will be walking you through my architecture. So here I will be having enough 5 steps. Let me walk you through the workflow. First one is the security checkpoint. So every invoice first enters a security checkpoint. This runs before any LLM is called and it redacts such as SSNs and credit card numbers, detects prompt injection attempts, blocks unsafe or malicious inputs immediately. This follows a zero trust design. So, unsafe data never reaches the model. Next one comes the orchestrator node. So, it's also called as an system orchestrator. So, if the input is safe, it moves to the orchestrator agent. So, this agent doesn't do heavy reasoning by itself. Instead, it coordinates the workflow and delegates tasks to specialized agents. So, next comes the extractor agent. So, it's used for invoice data extraction. So, the extractor agent passes the invoice and converts unstructured text into a clean JSON format. For example, it extracts the vendor name, purchase order number, line items, quantities, and prices. This is where LLMs add the most value. Next comes the verifier agent. So basically, verifier agents are used for data verification and validation. So the verifier agent checks the extracted data against enterprise records. So instead of hard coding logic, it uses a MCP server, that is Model Context Protocol. So why Model Context Protocol is used here to extract the query purchase orders, validate pricing and quantities, simulate ERP and accounting system. This cleanly separates LLM reasoning and deterministic business data. So, exactly how production AI systems should be built. Next comes the HITL. So, HITL, the full form of the HITL is human in the loop. If a mismatch is detected, such as incorrect pricing or a quantity, the workflow pauses. Using ADK's human in the loop capability, a reviewer must explicitly approve or reject the invoice before processing continues. This ensures accountability for financial decisions. So now I will be walking you through the live demo. So I have just created a demo. Like, yeah, yeah. So like input of the invoice. Here I have just given an invoice ID, vendor, and an EPO number, total amount, what are the items, and this quantity and their unit price. So after validating all this together, it will be providing whether it got approved or not. So for this, I have created a three scenarios. So scenario one, clean invoice. So I submit an invoice that perfectly matches purchase order. The verifier confirms all values using MCP tools and the invoice is automatically approved. Then comes the scenario 2. Here we will be having a mismatch. So next, I submit an invoice referencing 1003 as a number with an incorrect unit price. The verifier detects the discrepancy and routes the workflow to human approval, pausing execution until a reviewer responds to this. Next comes the scenario 3, where we'll be having a malicious or a sensitive input. Finally, I submit an invoice containing an SSN and a prompt injection attempt. The security checkpoint, as I mentioned earlier in my architecture, this security checkpoint ensures no leakage, no prompt injection, full auditability. Meanwhile, the MCP server isolates external integrations, allowing safe and inspectable access to enterprise systems without exposing them to the LLM directly. So, what is the business value? So, invoice processor reduces invoice processing time from days to seconds. More importantly, like prevents a billing fraud, enforces compliance by design, eliminates sensitive data exposure, keeps humans in control when risk exists. This makes it highly suitable for real world enterprise finance workflows. In summary, this project demonstrates secure multi-agent orchestration with ADK and MCP-based enterprise integration, pre-LLM security enforcement, responsible human-in-the-loop decision making. Thank you.